Green all the way. Green, orange. Okay. Why can't I do anything with this screen now? Hey, I've got a picture. Hello, picture. Hello. Well, that's okay then, isn't it? I suppose. But I can't see the... there we go. Stream health. Oh, wow, this is a big thing. Okay. And monitor. Let's have a look at our monitor. Oh, our monitor's not saying anything. Oh, well, forget that one then. That's no good. Live stream health. You are live. The internet can totally see you now. To stop, use your encoder. Oh, well, thank you. Thank you for your information. Thank you, YouTube. Again, YouTube decided to drop a bomb. But hey-ho. And hello to any visitors. Let's have a look at chat stream. Yay. Let's do the introduction, shall we? Welcome. This is Blades. Hiya. And yeah, it's Wednesday. I've got a lot to do, and it's shaders today. Everything else is working. So let me just get my work. Oh, here we go. Modifications I've made. Yeah, let's just pop through any modifications. Just put a printout in here, really. I think. But there was an error. Where was it? It was on colours. Anybody who was watching the last stream will probably be shouting it out at me, saying, "You've done your colours wrong, Blades." It was here. That was missing. Index size. For some reason, when I cut and pasted it, it dropped me index size. So index size equals amber : split matters. Because the index size for colour is bigger than the index size for normals. Yeah. Who would have guessed, eh? Who would have guessed? So, yeah, never mind. That was the only bit that was really bugging me in there. How do we do this? Oh, yes, it's on this keyboard. Well, hey, I've got a stream. I'm going to type something. I'm going to type, woohoo, it's shaders. Because today is shaders. Yeah. Finally, yeah. Oh. Do you want some good news or some bad news? Good news is, hey, look at my resources, peeps. Amber data, body, normal, position, texture, and texture name. Box, colour, normal, position, texture name. Head, normal, position, texture. Ding, 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 ding. Yeah, you can tell when it puts a texture in because it thinks it's a different style of coding. Silly Microsoft. Yeah, that's rather nice. So it works now. It's all fully automatic. Why was it not working at the end of yesterday's stream? Well, there's a bit of a story behind that, and it's called case sensitivity. Yes, I found out that it's case sensitive. So when let's go from the top and see if I can spot the mistakes that I made. All of this nice and doozy. Textures, oh yeah, modified that object texture size greater than 0. So that's been modified. Check for texture coordinates. Yeah. That's a bit better than what I had, which wasn't working too well. Let's just have a look down here. That's alright. That's okay, that's okay. Everything's okay there. Has textures works now. Let's have a look down here. I checked it and it wasn't working, by the way. So here we go, down into here. Yeah, there was a mistake in here. I didn't spot it until I had a thingy, one of these thingies placed here, and I was running through all of the lines in the MTL files, and it came up that the line was map_KD, but the K is uppercase, and I had a lowercase. Yeah, thanks. So that if statement wasn't working, and that's why we weren't getting texture files, because it wasn't working properly. So all of that works properly now. Anything else in here that I really messed up? Not really. All pushbacks are correct. I still haven't got through to that static cast. I'll do that after today's stream, I think, because it's boring doing that. What it means is I've got to go through that file there, revert it to unsigned ints for all of these m_reds, greens, blues, and all of that kind of stuff. And then I've got to go back through all of the utilities and make sure the unsigned ints work. So it isn't exactly a small job, it's a major overhaul. But I'll do it, I don't mind, because I want to do it. I want to do it. So that was me just printing out the number of positions to find out what the heck was going on with my positions array. So that can be removed. That was just a printout for me, a sanity check. So that's gone. The answer is 145 for the box, by the way, which is one more than it should be. It should be 144. I checked. And let's have a look. Yeah. That's okay. String converted. Yeah, all of these are working great. Which shocked me. Absolutely shocked me. Everything in this part is spot on, fandabidoze. And return has textures. Because I can. Don't need to anymore because I know it works. But that's fine now. All the OBJ utilities work. Done. Anything else I did? Yeah, I took out the button because it wasn't going to work in the situation that I put it in, and I don't want buttons anyway because I'm going to make them. I'm going to make a different buttoning system, and my buttons are going to be on 3D. So the I'm GUI buttons have been taken out. So really, we can just call this nothing. Do that, I suppose. Don't need those two lines, really, because I'm not bothered about it. All I want is that last bit. Blah, 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 blah. Yeah, I'll put it in here. Go on then. Just put FPS in capitals. I don't know how to scale this text yet. Is there another comma on these which I can use? Don't know. Great. Doesn't tell me. There. Let's have a look. var list args, var start, var text v, var end args. So there is a start and an end in a var list. I'm going to have to read up on that. Nothing much really, so I'm not really that bothered. Just me altering and being picky now about things. Is that needed anymore? Not really. So that bool isn't really needed, but it doesn't exist anymore. Let's get rid of it. I want this as simple as possible. Absolute waste of time doing all of that. Oh, where are you? Come here. Just want to do that. Take the bool off there, make it void. And that's it. So that now goes to that one there. Thank you. Get lost. Blunk. There we go. Everything's happy. It's just an FPS window now. I don't like FPS as a measure of anything, but it's the only easy measure I've got, so I'll use it whilst it's here. I'll probably drop that altogether later on, but it's there if I want to use it. It's dead small, the writing, but I'll deal with that some other time. Everything's working fantastic. Yeah, there we go. Let's do some shaders. If you want to say, if you want to ask questions about shaders, okay, let's do some shaders. If you want to ask any questions about shaders, please feel free. If you want to ask any questions about any other subject, please feel free. Even if it's a different language altogether. If I don't know the answer, I know how to find it. And that's what comes with experience, I suppose. Right, shaders. How long will we be on for now? A couple of minutes? A few minutes, have we? Yeah, okay. Yeah, right, we can start then. Let's start today, after we finished yesterday. Launch 9, make sure everything's okay, that we're in a good place. We are in a good place. If you notice, that hasn't redone. And that's because it's inside and I haven't redone that either. So run build task 1. Fantastic, thank you. Let's trick this one into running again. Just do that. I'll trick it into running the build task. Make sure everything's okay and everything's changed over nicely. There we go, FPS. That's all it gives me now. Oh dear, I touched it, sorry. Yeah, I know it's an exception, mouse button callback. Don't know why it keeps doing that, but hey ho. It seems to be liking its mouse button callback for some reason. I've got something wrong in the wrong place, that's all it is. Okay. Alright, so I'll look into that in my spare time and come back to you. But I think it's just that I've split everything up and it doesn't like it. But everything's in the wrong position anyway, so I don't really care. Get rid of development. I'm not interested in development today. Right, resources. Here we go. In our resources, we are using that. This is our vertex shader. This is the one I'm currently using. It will accept a position, a normal, and a colour. And the MVP, model view projection matrix, which I don't talk about much because people really aren't interested in the maths, I don't think. If you are, let me know and I'll talk about it. I know the maths inside out, upside down and backwards for that one. We are sending out of the vertex shader colour and normals. As you can see, we don't do much to them, except I'm putting that over to a Vec4 because I'm bringing it in as a Vec3. No reason to bring it in as a Vec3, but I do. So there, because I could, and I did, and I can. That's fine. I mean, the positions is fine. That's not what I want to look at today. So the vertex, I'll leave alone. That's your vertex shader. You put your version in. I'm using OpenGL 3.3. You do your layout, location 0, 1 and 2, which is here. So VBOs. Starts at position 0. Normals, position 1, 3, of course, times 3. Colour is now on 2, times 4, because it's a Vec4. And that's it, really. And then, of course, you've got your index buffer, which doesn't show up on shaders. So that's your 0, 1, 2. Position, normal, colours. It's got to all match up. Those words have got to match up. Those numbers have to match up. And these have to match up when we go to the fragment shader. We've got 2 ins and 1 out. So we've got 2 ins and 1 out. And we've got a V colour. That's not so clever, is it? Really, when you think about it. So that's the basic frag. What can we put in here? Let's have a look at this fragment shader. Yeah, it's a bit more technical, shall we say. Does a little bit more, because this has got textures in it. So surface normals are there. Right, so we need unit normals. We need the unit light vector and a unit vector to camera. We need the camera position, which is currently at 0, 0, 0. We're not even giving that, are we? We've got colour, we've got normals. Okay. We'll drop some space in then. And we'll see what we can do. Light should be uniform. So we could really do with a uniform, well, these here. I don't need the texture for this one. I do need these 3. These would help. So I'll copy those over. So we're going to have to find shine damper and reflectivity. That came off textures as well. Interesting. So I can choose whatever I like for those. Those should be given by the model or the entity. I'm not sure I want them at the moment. That doesn't make sense. Where is the light? Where's it? Where are we getting? Ah, here we go. Right, we're calculating this somewhere else. Okay, let's have a look at the static shader, vertex shader. It's doing a lot more than I am. It's got the MVP separate, that's all there. Uniform light position. I see. Okay. GL position, yeah. Text coord, yeah. Lighting, here we go. Let's have a look at this more carefully. Let's have a look at lighting. Lighting is tricky. Get it wrong, and you're in a lot of trouble. To get that, we need to know those. So those can go there. Why are we taking a surface normal? Like that. I bet it's being normalized. I don't believe I've actually got that. Okay, so we're not... Oh yeah, we don't give the colour, do we? So that replaces 10. All of those three uniforms are that uniform, and the only other uniform is that one. Light position, which I agree with. So that should be it. Going to me. Right, let's have a look and see what we're doing here. We're taking in the light position, and we are creating quite a few things here. The colour stays the same. I know that. The vertex surface normal is the model times the vec4 of the normal. The vec3 of the normal. Oh. Why be that? Well, I know it's relative to the model. So how's that working? That's the model matrix. What it's doing is it takes your normal and it places it in the correct position on the model depending on its rotation. Otherwise your normal will be in the wrong place. It will be facing the wrong way. So we are going to need you. And you are a matrix. So that's a uniform. And it's a mat4. And it's just whatever it is. U model. So we do need a model matrix. I know I need the light position, that's pretty obvious. So two light vertexes, world position. We don't have world position, do we? Which is model times position, if I'm right. Basic. Just go back up to split screen, please. And static shader, vertex, please. World position equals that one there. Vec3 U model times position. Well, we've got those variables, so we can work that out. That's not a problem. So that can go under lighting. That's okay. So we've now got a world position. So it's wherever the light is minus wherever you've put the model in the world. So that is that's looking at the positional point of view, whereas your normal is looking at the rotational point of view. Yes, that's good news. So that's okay. What else did we need? Anything else? No, I think that's it. Inverse of U view. Oh. That's your 2 camera. You got to invert the view vector, the view matrix. Times. Oh. Vec 4 of 0. Oh yes, because we're at the centre of the universe at that point. Minus world position. Yes, from the centre of the universe to the world position. Okay. Yeah, because got to remember the camera is always at the centre of the universe. It's the universe that moves around the camera, not the camera that moves around the universe. And that equation there is y. So I'm going to need a U view as well, aren't I? Yup. So uniform mat 4. So we may as well just put in the MVP for what it's worth. And there's a reason why we should as well. U view. Thank you. Thank you. So that may as well just be P. Perspective. I think that's probably what we called it. Oh, projection. May as well be. And then we can do that there, projection view model. Yeah, I see what you've done there. Yeah. Okay. Fine. Don't like it. Why do they keep that to Vec 3? Because you like positions coming in as a Vec 3. Well, it should come in as a Vec 4. I don't know. So that really can just say that. So it isn't MVP anymore. It's get it the right way round now. I was about to put it the wrong way around. It's projection, isn't it? Projection view model. Yes. Let's do it in reverse. You do MVP, so you do it backwards. PVM. Yeah, I know. So it's actually that. Copy to there. Paste. Times. Copy. That. Times. Positions Vec 4, yeah. Okay. So don't need to mess around with that. Copy of that. There we go. That's everything. You may as well do it that way, because that, by the way, is about 1,000 times faster than doing it on your CPU. That equation. Because GPUs are designed for it, where CPUs are not. It's quicker to pass in 3 mapped matrices than it is to calculate the matrix for 1, the MVP. Funnily enough, that's how I prefer to work it anyway, but yeah, you should always do your calculations or as much as you can with matrices on this screen. That's what your vertex shader should really be doing, is heavy matrix calculations. You shouldn't be doing it on your CPU at all. Yeah, you should be doing it on that side at all. Right, I'm happy with that. We've got the colour, we've got the normals, we've got a world position, which we can now work out. Why I've kept that at Vec3, I don't know. That doesn't make sense to me, but we'll deal with that in a minute. 2 camera is probably just to make it easier in your head. Keep it in Vec3, 3 dimensions, rather than keep it in 4 dimensions, which doesn't bother me. That's all because I ignore the 1. See, the 4th dimension is always the 1. If you want to know why it's always a 1, it's quite simple. When I press play on here, you get a 3D model on a 2-dimensional TV screen. And the way our brains interpret that to be 3D is that we have something called perspective. Now, if you have a look at perspective on your TV screen, it vanishes at the very, very centre in a tiny little dot, infinitesimally small. Well, if you put that dot as the centre of your universe, 0, 0, 0, and you always move around it in a circle, looking at it, then that direction is immaterial. So on a 2D piece of paper, it doesn't matter where you look at it from, if you keep the perspective dead still and you make that the centre and all you do is orbit, all you can do is orbit it, then you may as well give that centre a number so you can orbit it. You could have 0, you can have 0, but it's not wise, because division by 0 isn't possible on a computer. So we chose the number 1. You can put 2s if you want. It doesn't matter. It's just a convention that we put 1, because if you divide by 1, you don't need to. 1 times anything is meaningless. Anything divided by 1 is meaningless. Cuts out all of those equations for the circular motion, and just means basically that your circular motion becomes 1. Yeah, and that's how you get your 4th dimension. It's the centre of rotation of a 3 dimensions looking into its distance of the 4th dimension, with the 4th dimension being an infinitesimal point in the middle, with 3 dimensions rotating around it, floating around a fixed point. And that's the whole point of this. Why is it always 1? It's a fixed point. It's not a randomly chosen fixed point. It's just a convenient fixed point. Can be anything you want. Doesn't have to be 1. But there you go. Try changing it on all of your equations and see what happens. You can get quite strange effects out of that, and it's interesting, to say the least. Homogeneous position, it's called, or homogeneous, depending on how you pronounce it, or homogeneous. And it just means 1 position, homogeneous. Homo meaning 1, genus meaning position, or spot, or infinitesimal spot. Yeah, kind of thing. There you go. A little history lesson in how we worked out how to do 4D in 5 minutes. A very simple explanation of it, which is a damn sight more simple than you'll find in a mathematical book, which will go into the reason of 1. Wow. And show you all the equations and confuse you. And if you explain it properly, it just means those equations disappear, which they do. So that's how we do without it, we can't move in 3 dimensions on a 2D screen. Because what we have to do is we have to rotate around our center of our universe with the camera and move the universe around our 0, 0, 0 point and just call it 1 in the 4th dimension. So it's the same point, basically. Yeah. It's pretty difficult to get your head around as soon as you start thinking about it, but if you don't think about it, it's dead easy. I just don't think about it. I just think of it all as 3D. It's dead easy. I just ignore that because it's ignorable, which is why I can't understand why that's been done. Maybe you get the 1 minus 1 bit. Yeah, you could end up with a 0. Yeah, okay. Fine. So our basic vert is now complete. We now need to convert all of those over to our basic frag. So we have to make sure, just get rid of it for a second, split the screen, basic frag put on this side. What we have to make sure is that everything that comes out, which is why I made a block here, comes in. I've already decided that we can have those. So that block there is this block here. So that replaces normals. All you do is do that. Surface normals are a vec3. I'm still worried about that because we're replacing a vec4. All these change to in. Right, that's correct. So I've now got all of these to play with. Yay. Yummy, yummy, yummy. I told you, it's great. I love shaders. Shaders are fantastic, but they can get problematic if you don't do it right. Do I need the light position? No, I've got that. And it comes in as a vec3. Okay. Okay. That's all correct, actually. Normal at 0. I don't like that, but it's correct. Funnily enough, it's one of those times where you don't put a 1.0 at the end. Oh God, after saying all of that, I've just spotted the one exception to the rule. There's got to be an exception to the rule, isn't there? Because that's not in 3D. Sorry, no, yeah, that normal isn't in 3D. That is not a position. That is a vector, and a vector has magnitude. It doesn't have a position, so it's 0, 0. Correct. Yeah, that's okay. It just keeps as a vec3 anyway, so it doesn't matter. It drops that 0, 0 anyway. That gets dropped. So that's why it's coming out as a vec3. Okay. Normal, yeah. Colours are okay. They're going straight through as a vec4. That's all vec4s. Those are all mat4s. That's correct. That's correct. That's correct. That's correct. Darn it. We've got a vert. Wow. That's what we have to play with. Yay. That's when it gets fun. Okay, so there you go. That's the basic vert done. No, it's not basic, but it's going to be our vertex shader. We'll test it as a basic vert, and then we will transfer it into our server color vert. This is going to be used for the server. I think I'm going to use the same shaders initially for the client. No, I'm not. The lighting changes completely. Oh no, it doesn't. It does to a point. Literally. Anyway, yeah. That's okay. We're looking good. We've actually got a shader already. Finished. Yikes. Got to go through all of this Phong stuff again. Okay. The shader variation that I use is called the Phong shader. That's Phong. Made by, or devised by, Mr. Phong. Possibly. Don't quote me on that. I'm just guessing, don't worry. Now, how are we going to do this shader as a Phong shader? Well, let's have a look at the Phong shader in fully, first of all. It comes on static shader FS. There we go. Here it is. The Phong shader is split down into 3 parts. It's ambient, diffuse, and specular. AD and an S. Which is why we have in our models, just trying to think where it was now. It's in here. Let's have a look. OpenGL. It's in H. Here we go. Which is why we have ambient colour, diffuse colour, which we're using, and specular colour. Because those can change with lighting. So you can actually have 3 different lighting colour structures if you so wish. These are available to us. They're actually recorded in there. Let's just have a quick look, see if I can open it. So MTL, OBJ, MTL it is. So here, ADS, ambient is at 1, D is a colour, and specular is at 0.5. No thanks. But these numbers are available to us if we want to use them. Well, why didn't I choose to use them? That's because I wanted to use this static shader here instead. And it does it all for us. It does the calculations for that. So as you can see, we have got 3 vec3, so it's normalizing. Oh, it's normalizing, but it's from a calculation, so I'll let it off. Normalizing, normalizing. You see how it's normalizing everything down to a unit vector of 1, size 1. That makes the calculations very easy because 1 times anything is the same thing, and 1 and divided by 1 is the same thing. So it makes all our calculations down to like just a dot and reflect dot and to the power of damped factor. Yeah. So yeah, I think we'll just keep all this the same. So what you do is you do your lighting, your final lighting comes out as this Vec4 lighting, and then all you do is you times your colour by it. Not your texture in this case, but your colour. So it's exactly the same as what I've got here. Copy. And I can now go to basic frag. And I can paste. So it's lighting times color. Yeah. Because it's a vec4 times v color of vec4. Good. There we go. And that's it. That's all I have to do. And it should all work. If we plug all of these numbers in now, it should work. But now we have to give these uniforms. All of this lot is given for us. It's coming out of everything else, isn't it? Yeah. So let's run through it. What you do is you make a unit normal. So you take your surface normal and you make it the size of 1. The light vector, the 2 light vector, so the light to your object, and from your object to the camera, you also make unit vectors. So that's the light going to the object, and that's what we see of that light. So that's from the object to us, to the camera. Okay. Hope I've explained that all right. The ambient lighting is just whatever we want. So that's my background lighting. So when you make your background, it should be the same as this. So that should be your background color. Mine's clear at the moment, so it doesn't matter. Diffuse lighting, direct from the light source. So that's the light that's hitting it directly from the light source. It uses the light's color and light's intensity. Now, where are we getting light intensity from? Oh, sorry, that's the dot unit light vector. Yeah, the unit normal. So the light intensity is the angle at which it strikes the object. It's calculated from the angle that it strikes the object. So that light intensity, we just times it, the color, the light color, which will be 0.8, 0.8, 0.8, if you want to know what that is going to be. And I can't remember, it comes in as a 3, doesn't it? Light color, yeah. So it's 0.8, 0.8, 0.8. Specular lighting is the reflected amount of lighting that's coming back to the camera. So your specular factor is dot. You can always see it's a dot. Dot product it's called. So the dot product of the amount of light that's coming back down that reflected light direction, which is calculated there, reflect. So that's how to calculate a reflection, and that's how to calculate how much is coming down using the unit vector to camera. Coming down that unit vector, how much of that light, that reflected light, is actually going to hit the camera from the angle that's given by the reflection. We then damp it by, to the power of specular factor and shine damper. So we can damp the shininess. The specular light itself becomes the damp factor times the reflectivity times the colour of the light. So that produces a glittering effect, or specular glittering effect. Yes, that's a good way of putting it. Now, if we were to put all of this into the vertex shader, it would only do it per vertex, and you would get a condition called faceting, where you would have big globs of specular, and all your shininess would look as if it was triangulated or squared off or whatever, and you would just look like a damn mess, to be quite honest with you. It's not too bad. It's damn quick though. It's a damn quick way of doing your lighting, but this, look at how much there is to do. Not a lot. All of these are special functions given by your graphics card. These are hard-coded into your graphics card. These are on a chip. These are not a language. You're opening and shutting gates on a chip. I can't give a word to say how fast this is. You're talking... the graphics card could probably do that 60 million times a second. Yeah, it can do quite a lot of it. So this ain't gonna take long. And this is basic. That's your basics. So I've just talked through it. Your final lighting is your specular light plus your diffuse light plus your ambient light. And it's all clamped, so you can't go past 1. So that's it, really. Specular light, why has it gone down to 2, comma 0, comma 1? Oh, right. So you got your first, second, third. Got you. Yeah, okay, sorry, my bad. Thinking wrong again. Deary me. Final fragment colour is obvious. So that is actually spot on for the texture, but not for our... All we do is change the last bit from texture to colour. It's that easy. Now if we can provide all of this information, I can show you. I can show you it working. So how do we provide all of this information? Well, we start off with our basic vert that we've just changed. And we find out what information are we giving, what information have we got. So we need to give those uniforms. So that's our first list. That's our priority next. So we copy those and we come back to our project. And under development, we'll just pop that somewhere. So where we'll be giving the MVP is the question, because that's where it goes. So it was under render, MVP, true, blah blah. So it's here. So all of this lot goes here. Just block that out, please. There we go. So in the development area, we are looking under the warehouse. This is the warehouse. So class. It's in a class. Yes, I'm making a class called Model Warehouse. And now this is going to get very, very complicated now. So we're getting to the stage now where we really should be thinking about pulling this out into a renderer. I think at this stage we really should. Otherwise, maybe not, because this is just going to, like, that's 1, 2, 3, 4 times that. 4 times that is what we've got. Map 4, and Vec3. So it'd be 4F, 4F, and 3V. And we need all the locations. Yep. So we need a model view projection location. So that's an MVP location. And we need a light position location or light location. LPOS. And they are in the initialization stage. Just up here. And we've got to get all of these right. Oh, that's easy to do because I did that. So it's copy. Let's start with this. I'm just going to alter these and then I can... So that is now M location. No, model. Yeah, why not? Got all the matrices. Class. Display. Where have I put it? Here we go, unsigned. Oh, right. Is that what I've done? Okay. What I'll do then is I'm going to put a semicolon there. And I'm going to put unsigned int. And it's going to be model m_view. I'm just going to call it lock. And we've got projection. Oops, m_projection lock. I'll have to abbreviate that or it gets too long. And that's that lot. We now need a few more, so it's another unsigned int. And it's m_something or other. Okay, just take that off there for a minute. What else do we need? Light position. Light pos lock. Light pos lock. There we go. So I'll just put those in for a second. So here, alright, just copy. Yeah, I think we can do this alright. 1, 2, 3, 4. So that is model, view, projection, and light pos. There we go. Oh, don't do that. So that is u_model. Yeah, that's right. Model, view, projection. And I can't remember what the last one's called, but I'll call it light position, because I think that's right. Yep, that's right. Yep. Right, so I've got all of those. That now no longer exists, so that will be model. Hmm. 0800. You think I'm answering an 0800 call? I could reject call with message. That would be nice. M_model location. Lock. Right, that's correct. Number of... Oh, shut up. M_model lock. 1. Yeah. And... We need variables for it all. M underscore model matrix. I'm going to call it. We're going to need some mat4s here. Oh, we've already got them. DAR. And a vec3 for the light location. Okay. So amber vec3, and that's m underscore light position, which I can make up randomly. I don't mind. Shh, don't tell anybody. I make a lot of things up randomly. That's okay, that's okay. Projection matrix. Oh, I did it all in full. That's clever of me. That's thank for that. There we go. That's a model matrix. R0C0 and an HGL true. That's correct. Fantastic. I can do 3 more of them. That's easy enough. That line isn't needed anymore. Oops. Copy. That's 3 more of those. That's model lock. And it's view. Lock. And it's view matrix. Lovely. This is now proj lock. I put it in full, did I? Yes, I did. Projection. There we go. And then we need one more. We need a GL uniform. It's not a matrix. It's going to be a 3. Is it a vector? Does uniform matrix doesn't do vector? Okay, but it's a 3v, 3 integer variables, or 3f. I just want 3f. I don't really want the v. Oh, it's in a vec format anyway, isn't it? Yeah, okay. We'll try that one. See what it wants. Ah, doorbell. Just 1 second. Be right back. Hey, now I've lost my train of thought. Ah, lovely. So how's your week going, eh? My week's going okay, thank you. End up talking to myself if I'm not careful. Yeah, what was I doing? Oh yes, I was looking at this, wasn't I? GL size I count, const, GL float, star value. Huh? That's not right. That doesn't look right. Why have I forgotten how to do a vec3? I mean, I can do what it asks, but it's not going to give us the light location. Okay, I'll look it up. OpenGL notes, shaders. We have some somewhere. Where are they?